Hello and welcome to Algebra 1, Credit 3. We're going to be going over the practice test before you actually go in and take the test for Algebra 1, Credit 3. We'll start with the first one. It says solve for b, which we're going to be making this variable by itself. As you can see, there's some other stuff there that we need to kind of get rid of. So what we'll do is, I'll draw out line here. We want to get b by itself. And right now, there's a 3 being multiplied, and there's an a squared being multiplied. Well, my question to you is, knowing what you know about solving equations, what is the opposite of multiplying? Dividing, right? So the opposite of multiplying is dividing. So we're going to divide by 3, and we're going to divide by a squared. All right. So 3 divided by 3, that's just 1. A squared divided by a squared. Anything divided by itself is going to be 1. So I'm left with b on this side equals r divided by 3a squared. And I have essentially solved for b. Okay. Go on to number 2. It says, what is the solution to this equation? All right, so we went over absolute value. We want to get the absolute value by itself before we do anything else. So again, I'm going to draw my line. Okay, and I'm going to get rid of first what's being added or subtracted. I'm going to do that first. All right, so what's being added or subtracted here? 3, right? It's being subtracted. What's the opposite of subtracting 3? Adding 3, right? I'm going to add 3 to both sides, and that cancels out because 3 take away 3 is just 0. All right, and 7 plus 3 is 10. Okay, I still have that x in an absolute value divided by 2. Now that's being divided by 2. What's the opposite? So we're going to get rid of whatever is being multiplied or divided to the absolute value. Right now there's a 2 being divided, so what's the opposite of division? Right, multiplication. So we'll multiply both sides by 2. This is going to cancel out. I'm left with the absolute value of x equals, what's 10 times 2? 20, right? Now, a lot of students would be like, okay, that's my answer, but actually there's 2 solutions here, because if you remember absolute value, right, I can put an absolute value of 4 will get me 4, and an absolute value of a negative 4 will still get me 4. It just has to do with the distance on a number line. So even though, yeah, my 4 is here, it's still 4 away. And even if I'm at a negative 4, I'm still the same distance, 4 away. So no matter what number goes in here, it'll come out positive. That means that I could have put x could be 20, right? Because absolute value of 20 is 20. Or I could put x equals negative 20, because I know if I put a negative 20 into these absolute value bars, I'm going to get 20. So my answer could either be 20 or negative 20. And just for continuity, so no one feels left out. All right, so you have a word problem for number 3. It says, at the same time of a day, a man who is 66.7 inches tall casts a 71.3 inch shadow, and his son casts a 31 inch shadow. What is the height of the man's son? So in this credit, you also went over ratios. So we're going to set this up as a ratio. All right, so we're going to set up, here's the man's height over his shadow. So man's height is 66.7, and his shadow casts a 71.3 inch shadow. His son, we don't know his height, right? We're trying to find his height. So what What variable do you want to use? Most people just choose x, but you can use whatever variable you want. And then the sun's shadow length is 31 inches. Okay, so we've set up our proportion, height over shadow length, and what we're going to do is we're going to cross multiply. Okay, not across like across, across like across. Okay, you'll multiply those two and you'll multiply these two. Okay, and since you can't really use a calculator, I'll make sure to do the computations here, but that would be 71.3x. So if you multiply those two, just to repeat, 71.3x, if I multiply 66.7 times 31, I'll get 2067.7. That's 2067.7. So right now I'm multiplying by 71.3. What's the opposite of multiplying by 71.3? Dividing, right? So I'm going to divide each side, all right, by 71.3. 71.3. If I divide, and hopefully you have access to a calculator, because if you're not able to set it up, you know, a calculator can only help you so far when you actually get to this point, but if you're not able to set it up correctly, of course your calculations will be wrong, but if you set it up correctly, 71.3 goes into 2067.7 about 29 times. So that means that the sun's height is about, in inches, is about 29 inches. Okay, so let's move on to number 4. It says reduce 74% as a reduced fraction. So you know 74, you know money, right? So if I had 74 pennies, right? How many pennies are in a dollar? 100, right? So it's pretty much like I'm saying 74%, keyword being cent there, I have 74 cents out of 100 cents, right? So a lot of students will be like, okay, well that's as a fraction, but they want it as a reduced fraction. So what I'm going to have to do is simplify this fraction. Well, let's go ahead and figure out, well, what are some numbers I can divide into, or divisible into 74 and 100? Well, I could try 1, right? But is it really going to change anything? How many times does 1 go into 74? 74 times. 1 goes in 100. It doesn't really change anything. Let's try another number. Let's try an even number since they're both even. Let's try 2. Let's divide both top and bottom by 2. Well, half of 100 is 50. And half of 74, that's 35, and 2 makes 37. A lot of students, if you want, you can have your calculator and say, let me see if I can make it small again. Some students want to go that far, right? Like, oh, well, half of 50 is 25, but if you split this in half, right, that's 15, that's 3.5, that's 18.5. When you reduce, you don't want a decimal. So if you're, dividing or reducing and you get a decimal as your top or bottom, you've gone too far. So this is not something you want to do. Unfortunately with here, and some students will, let's try 3, let's try 5. If you want to try that, that's fine, but actually this right here is going to be our reduced answer. Okay? But some numbers to work with, you always want to try out if it's divisible by 2, divisible by 3, 5 is always a popular number, but don't be surprised if it's a 6, a 7, or an 8, just because these ones are the kind of the toughest times tables, and sometimes we just kind of want to put that in there, see if you remember your times tables. Go on to number 5, it says 30 is 50% of what number? The best way to kind of go over this is actually to translate it, okay? So 30, the word is actually means equals. Like if I said 2 plus 3 is 5, right? It's like saying 2 plus 3 is 5, okay? That's why that is kind of goes in there. But let's continue, so at least you know why it is equals 50%. I'll leave it as a decimal for now. That's going to change, though. Of, the word of actually means multiply. And of what number? I don't know what number I'm dealing with, so what I'm going to do is I'll put a variable. So my variable is going to be x. You can choose whatever variable you'd like. Now we have an equation to work with, so I'm going to write this over a little bit because I'm going to solve it so I can figure out what number that is. All right, now a lot of students want to leave that 50% as a percent. You might want to change it to a decimal. So what would 50% be as a decimal? Would that be sorry about that. Would that be 0.50 or 0.05? 0.50, right? It's like 50 pennies. Like 50 cents. Okay? Times x equals 30. So let's solve. Right now we're multiplying by that 0.50. So what's the opposite of multiplying by 0.50? Dividing by 0.50, right? So we're going to divide 0.50. All right, again, if you have a calculator handy, your number would be 60. Just see if that makes sense. If I take 50% of 60, so if I take half of 60, would that not be 30? Half of 60, isn't that 30? Yes. I just want to check to see if it makes sense. But yeah, my answer would be 60. All right, so it says number 6, a department store purchases a suit, nice suit. I like to draw, if you can't tell. Not a very nice suit, but whatever. $85, right? And then it says this to sell to customers, it increases by 22%. And that makes sense, right? The store is not just going to sell you that that suit for $85. They wouldn't make a profit. They're going to increase it not by an amount, but a percentage, right? They're going to charge you the $85 plus something else, which would be the total new price of the suit. All right, so now you have to figure out what that 22% increase would be and what the new price of the suit would be. So I know they're going to charge me $85. I know they're going to charge me 22% of, they're going to charge 22% of the original price, which was $85. All right, so I'm going to figure out what that upcharge would be, and then I'll add it to the 85 and figure out how much money am I going to really be paying for the suit. So that's, change that to a decimal, 0.22, that's multiplying 85. Again, sorry if my times tables looks like a decimal, but if you multiply this together using your fancy dancy calculator, that would be 18.7. So it's going to upcharge about $18.70, but that's not the new price. We have to add it to the $85. So $85 plus $18.70 would get me 70. Would that be 3? Carry the 1. About $103 for that new suit and 70 cents. All right, let's go on to number 7. It says write the sentence as an equation. So it says 5 times the sum of negative 13 and 2 amounts to 55. Negative 55, I should say. All right. We're not going to solve this out. We're just going to write it out. Okay. So first thing I want to do is say, okay, 5 times, well, times just means multiply, right? Now it says the sum. The sum. So I'm going to add these two numbers together. I'm That's what sum means. It means to add. Times means to multiply. And we're going to be adding these two numbers. So these two numbers, okay, and the word amounts means equals. It's going to get to, it's going to be negative 55. You might want to take a card of like certain words that you're going to need to know, like time, sum, things like that, so that way you can have that ready for the test. It says, we're actually going to skip this for right now. I'll come back to this in another YouTube video, but I don't want to spend too much time on one question. Each point, by the way, each of these questions is worth 1 point. So conserve your energy. It says, how many different ways can you, how many different arrangements can be made with the letters Iowa? So what I like to do is actually do a list of words or a tree of words. So if the first letter is I, well, here's one arrangement, right? Here's another arrangement. Like, what if I put the A-O-W? What if I put, right? What if I put, is there a different way I can write this? Where O is last? Or, okay, so that's 1, 2, 3, 4, 5, right? 5 different arrangements I can use. And I go through each letter, like let's, instead of I being first, let's put O to be first. All right, so that's O, W, A, I, or O, A, I, W, or O, I, W, A. What's a different arrangement? Okay, how about I, A, W? How about A, W, I? How about, what are some different ones? So that's two. How about O, W, I, A? So there's a couple. So you might want to go through this list and just keep a count. It's only 4 letters, so you can kind of do that. Not that bad. And then you can figure out how many different arrangements there are. And by different, they mean like everything's different. So I wouldn't put any repeats on there. All right, so number 10, it says, which statement is true? So what I would do is go through each statement, and I'm going to be looking for the truth, because we're all in search of the truth. There's going to be 3 lies that I'm going to have to eliminate. All right, so I'm going to evaluate each statement. It says that negative 8 is less than 1. Or if you want to think of less than as or equal, if it's worse. If you want to think of negatives as bad numbers, bad things, and positives as good things, so bad, good, is negative 8 or 8 bad things worse than 1 good thing? Well, yes, bad is always worse than good. So actually, we kind of found our statement in letter A. But I'll just go over these just so you can kind of see what I mean by a lie. So for example, 2 is less than or equal to negative 5. So you can say 2 positive things, 2 good things are worse. Are they worse though? And 5 bad things, right? Is that true? No, that's a lie. Dun, dun, dun. But that's what you would do on your multiple choice test. Go through each statement and try and find the truth. Go through this one, solving inequalities. That was so huge in this exact packet. So let's solve. So I'm going to pretend like this is an equal sign. I'm going to solve pretty much the same way with a slight difference. So I'm going to get rid of, again, what's being subtracted. Okay, I'm going to move that over. What's the opposite of subtraction? Adding, right? So that would be what? 1 negative, 2, 3, 4. Whoa, sorry about that. So that'd be 5 positives. So I put this here, 5. Now, is this going to be a closed circle or an open circle based on my inequality? Open, right? And which way am I going to shade? This way, right? Let's solve this one out. Again, how do I get rid of a positive 9? I'm going to subtract it, right? X is less than or equal to, what's 9 take away 9? 0. So put 0 here. Is that going to be a closed circle or open circle? Closed, right? And which direction am I going to shade? That way, right? One of my students let me know that. They're like, oh, if it opens this way, it'll shade that way. If it opens this way, I'll shade that way. Try this one. Right now I'm multiplying by 5. What's the opposite of multiplying? Dividing, right? Divide by 5. 5 goes into 24 times. If you want to graph it, you can. You just have to solve for number 13. Number 14, same thing. Right now I'm dividing by 5. What's the opposite of dividing? Multiplying, right? Yeah.
And then she didn't type something in here?
Sure. Sorry. All right, so if I multiply by 5, let's do a little quick arithmetic. That would be 5 and 4, 24.5. You just have to solve it. You don't have to graph it. Next one, you'll go ahead and get rid of this minus 2. So we'll add 2, add 2. So that's 2x less than 6. What's the opposite of multiplying? Dividing, right? So that's x is less than 3. Again, you just have to solve. For number 3, so we're going to solve this one. We'll move all of our variables over here. So that'd be negative 1b. Move our negative 6 over here by doing the opposite. All right, and we're going to divide by a negative 1. Now, if you do divide by a negative 1, you will actually have to switch the sign, this direction. So just keep that in mind. So when you divide by a negative with inequalities, you do have to switch directions. We're almost there. Last 3 questions. So when a number is multiplied by 4, the result is less than x. So we're just going to write it out. We're not going to solve it. So this is when a number, x, is multiplied. I'm going to multiply by 4. The result is less than x. So less than 8. So you can write it out like this, or you can write it out like this. Either one is fine. Again, you do not have to solve it. All right, so it says Alicia's received a $70 gift certificate. So for like a gift card for 70 bucks. She can only spend that much. She can spend less, right? She can spend 60 bucks. She can spend 50 bucks. She can spend 69.99 of it, but she can't spend like, so this is okay, this is okay, this is okay, but she can't do like 71.50, right? All right, so it says that the boutique, she wants to buy some t-shirts and some socks. So it's $8 each for the t-shirts. So for every t-shirt she buys, it's about $8. And for every pair of socks she buys, it's 3.5 per socks. So I know she can only spend about 70, so she can spend right up to $70. So I'm going to leave kind of an equal sign, but she can't spend any more than that, right? So a lot of students, when they think, oh, well, I can't spend any more, no more than, a lot of students want to use this symbol. But remember, she can only go up to that limit. So it could be less money, it can't be more. Less is the key concept here. So I'm going to use that. So 8 times the t-shirt and 3.5 times the socks, less than or equal to $70 on her gift card. Try 19. This one we do have to solve. It says twice the difference of a number and 12 is at most 70. So twice means multiplying. The difference means subtraction. A number, a variable, and 12 is at most. So again, it can be less, but it can't be over. Okay, so it can be less, but it can't be over 70. So we'll solve this out. I distribute. Move that over. All right, so that's 94. Divide by a 2. Now I'm dividing by a positive number, so I don't need to switch. And that's x is less than or equal to 45, 47. Oop, don't forget that inequality sign. Last one. So it says Lev earns $5.50 an hour for every hour. So if they work 2 hours, it's double that. 3 hours, triple that. So $5.50 an hour after school. He needs at least $305. So he can have more. He can have $350, $400, $500, but $305 is the minimum. So it says write an inequality. So it could be 305, so it can be equal, but it has to be a minimum. So a lot of students, when they think minimum, they think, oh, I'm going to put less than. Remember, it can be more. I'm actually going to use the more than or equal to. And if I actually solve this out, that would be 550 divided by 550, and I could find out that the number of hours he'd have to work bare minimum to get that stereo system would be, so again, using your calculator, you can use it for the test, would be about 55 hours. If you want to round up, about 55 hours, okay? Maybe 56 hours, but either one's fine. All right, so if you have any more questions, please let me know, and as always, good luck on the test.